So let's start by introducing you with me. So my name is Aivars. I've been in IT for about 20 years. About last 6 or 7 years, I'm working with the Kubernetes daily. For 10 years, I'm working in iGaming industry. So also when I started to contribute to Kubernetes. So I'm a Kubernetes organization member. I do the voting and etc. So once I was also the maintainer of KubeSpray, which is actually the Ansible playbooks for deploying the Kubernetes clusters on premises. So, and I'm really big fan of CNCF ecosystem and everything around it because I like how the job is being done. What's not written here is about my hobbies. I'm doing a lot of those also. I do hikes in the mountains, I do the surfing, I do the orienteering, I do the bikes, the supping with the boats on the rivers, etc. So that's me. But let's skip this non-interesting part and go further. So what's the Kubernetes operator? So that's an introduction. So you mostly know what is Kubernetes operator and what it does. So basically, the operator is the software version of people who operates the cluster. So as we all know, where is people, there is mistakes and errors, etc. So we try to automate everything. And the Kubernetes operator is one of those things which can help us here. So what basically does the Kubernetes operator? It watches the mystical term, the custom resource definition, and does what's it written there. So basically we have a custom resource, it sends events, and it watches it and just adjusts the state, and everything else is being done in the Kubernetes. So you expand the Kubernetes, the core Kubernetes with the operator. So what's the operator? That is the operator pattern. So it allows you to expand the Kubernetes functionality without touching the Kubernetes code. And it's a really nice thing, because if we would like those all Kubernetes operators which are out there in the world to be integrated in a Kubernetes, the Kubernetes code base would be really large. And it would be really hard to maintain, which is actually true already today within the basic Kubernetes core code. It's really hard to maintain it, and the testing is costing a lot. So, next one. So what types of Kubernetes operators there are? There are custom operators, which are specifically designed for your tailored needs. And then there is a community operators. So operators provided by the community. There are a lot of operators. I will talk about them a bit later. So let's start about the core components. So I already mentioned custom resource definitions, or CRDs. So that is a way how we define the custom resource and represent the state of the application, what we want to achieve. Then there is a controller, which is basically the operator itself, which does the reconciliation loops and tries at least to make the application state desired, so senses it. And then there is an operator SDK, which is actually the tools and the frameworks like operator SDK, so the development. About each of those I will be talking in this presentation a bit later. But let's start with the custom resource definition. Yeah, it's kind of small, but it's just a simple example of how the custom resource definition looks. So basically this one is the custom resource definition. As we can see, the group will be example crd.com, the scope will be namespace, so you can create the stars which are namespace. And the stars have actually the specification of two required fields, the type and location. And there is also the what type of code it should have. So basically what we are all becoming by using the custom resource definitions, we are becoming the YAML engineers. This is just some basics. The real custom resource definitions are really pretty long. So what does the controller does? It's actually all the time analyzes, observes, and acts on events. So it checks the actual state, it checks the desired state, does the diffing, and if something is not matching, tries to apply the desired state to the actual state. And all the way, again, everything like that. So operator SDK depends on in which language you are fluent. So there is a Java operator SDK, there is a COP in a Python, there is even one in Rust or .NET. So there are a lot of different SDKs for the operators. So from my experience, my first operator was using COP. Now I am using the shell operator, and I'm starting to develop things on an operator framework. There are more of those. Those are just examples. So why do we need to do this? So imagine you have routine tasks which are repeating from day to day, and you're already being tired to do those. So you need to think of a way how to automate them. And here comes actually the operator help, because it can take the source of information, do the transformation, and decide what to do with it based on the input. Then the next thing is the consistency. So if you have a lot of different types of inputs, you can try to normalize it, and then the application deployment with the environment variables or specifications can be achieved in a consistent way, because the operator can morph this data so it can be in a consistent state. So what it does more, it's actually self-healing. So the Kubernetes core components takes care of self-healing mostly, because the operator just deploys the thing, and then the Kubernetes core does the rest of it. And it's really, really good extensibility, because it allows to extend with a custom logic. And basically, you cannot tell that you cannot do it. It's just a matter of approach, and if you choose the right approach, then you can do it. So, yeah. Use cases. So the database management, managing stateful applications, Postgres, MySQL, Kafka, Cassandra, whatever. So as a middleware, managing message brokers, caching systems like Redis, etc. Any other middleware. Ingress controller, actually, it's the same operator. It just takes the custom resource, generates the ingress rules, and you can reach your service. So, and then it's easy to do the application lifecycle with the operators, because it's software at the end, and you upgrade it like with the similar way like a software. So here is a Prometheus operator. It's one of the most used operators in a Kubernetes ecosystem, because what it provides, it actually provides the possibility to monitor each service pod, whatever you want. And this is somehow a bit of architecture. It's a bit bigger actually. This is just the basics. So in a Prometheus operator, you have different custom resources. So basically you can deploy multiple Prometheuses for each team, separate Prometheus, and the data is not crossed between the teams. So you can monitor the service. Actually, what the service monitor does is it discovers the endpoints and then monitors the endpoints. So it's in scope of one service. Then there is a pod monitor. Pod monitor can be a bit wider because you provide the label set with which you select the pods to monitor, and that could be across multiple services, multiple applications, and you need to add only one pod monitor or 10, and it will be monitored. So then we have actually also the Prometheus rule, which is actually defining on when to alert on different metrics. And then there is alert manager config, which provides the different types of delivering those alerts to users. It could be email, it could be Jira ticket, it could be Slack, Teams, Ops Genie, whatever. So, yes, I think I told everything about this pretty fast. So here will be some our cases, what we do in our company. So we have mixed environments, mixed deployments. We have on premises, which is actually pretty big because of the iGaming standards and needs. Then we have also the clouds. We have different clouds. We have different DNS providers for different domains and etc. So we need to configure them somehow. In a cluster, it's easy. You just run external DNS, configure it to your DNS provider, and it's been discovering the DNS names from the ingress, and it's everything okay. But what if you have a lot of on-premises and you need your internal DNS also in the DNS? So here comes actually additional application to help in our case. So we have the DSIM IPAM system where all the teams add their devices. So we have like around 2,000 of them. They are not just on one on-premises, they are on different on-premises. So they all, upon the installation, gets registered in our system, and then we have additional application which discovers that infrastructure from that system and adds the DNS endpoint custom resources in the cluster, and then the external DNS configures those DNSs based on the label sets in which cloud provider it needs to configure. What it gives us, we can configure directly in a DNS. So first of all, we remove the people who are doing the job, so less errors, less forgetting, etc. Then we don't need to think, okay, this zone was in which DNS provider configured, so we need to go seek that. In this case, it's already configured in external DNS. We just forget about it. Everything is happening and we are saving the time. Next example is actually also really good. The Cert Manager. So Cert Manager, basically what it does, it manages your certificates, public ones, internal ones. So we are using also the Let's Encrypt with the DNS challenge. So for Kubernetes workloads. But we have on-premises which needs to talk with our Kubernetes clusters in the cloud using MTLS, so mutual TLS, and we use our internal CA with this, and also we have middleware application with the API, which is protected with the tokens, and then our internal infrastructure, when it starts, it goes to the service and requests the certificate. That application goes actually and creates the custom resource for the Cert Manager, and the Cert Manager is issuing the certificate. So we go down on the scope of our needs and we split those between our own application because of our custom needs and also the community provided application, which is working and working nice. Oh, yes, thank you. So, questions maybe? Yes.
You said that you use the shell operator. Why?
There are some pretty simple cases where we don't want to spend the time to write something big. So we just select different data from the cluster with the shell operator and send it to the Slack channel, so we can see at some point in time what's happening, also on events. So we use a lot of, actually, as I said, mentioned already, we use Kafka operator, we use the StreamZ, so different usages. We try to find that one which requires the less job to make it work. Yes?
What is the like? What is a use case? What you can tell about us publicly? What you are most proud of from the using operators? The most wild or most wildest one?
Most wildest one.
Yeah.
It's really hard to say because there are a lot of those. So I had actually the COP which I used to write and operate it by myself. The first time when I learned Kubernetes 6-7 years ago, it was actually the application which was starting the containers of a request in some backstage application. So the product managers, let's say, check the checkbox, and then the container is being launched. When they don't need it, they checkbox out, and etc. The application was actually working with the video streams and consuming data and doing the analytics on the video. So we also use the Argo CD. We use Kyverno. We use a lot of different stuff. I cannot call everything what we use, but it's actually taking a lot of resources also. So we are trying to see what we can squeeze into different things. Oh yeah, last week we launched actually the Grafana operator for different teams, different dashboards, but the dashboards are stored in one Git repository, so they're being filtered out based on labels from that one specific repository and distributed across the Grafanas. So yeah, fun things. Yes.
So you're a true Kubernetes believer.
Yes.
Let's say I have a rather simple use case. I have a Postgres server on some hot standby mode, and I want to go HA. Without Kubernetes, this is what I have on a couple of virtual machines. That's
Okay.
it. And I need to go HA. That's complicated about using standard the Postgres base tool. You need to have some knowledge how to put it together.
Yes.
Here you're saying just use
Yes.
the operator and it's going to work for you. So what is your suggestion for my case? Because deploying a whole Kubernetes cluster just to have the HA also sounds a bit crazy, doesn't it?
Yes. As you said, I'm a Kubernetes believer, so you should go deploy in Kubernetes. It's in a long term, it would pay off because you don't need to do a lot of things under the hood. So operator takes care of that. Under the hood in an operator, it uses the Patroni with different bunch of stuff which I don't even know. So if no questions anymore, then thank you.